Okay, so everybody went on to Blackboard. They went to week 6, downloaded chapter 5's LAN WAN file. You can remember this from the last lecture, last week if I remember correctly. I was introducing the concept of ARPing and how when one node wanted to know about another node's physical address, it would send out a message called an ARP request to the switch. And what would the switch do with that message? Remember, this is an ARP request.
Send out every
It would broadcast it to every other device connected to the switch, asking, hey, if you are this particular device, 192.168.1. something, can you tell me what your physical address is? Why would this end device even bother with a physical address? Why would it need to do an ARP? I mean, we're in this middle of communicating. We are stopping the process to go out there and find out what the mailing address is for the other host. This hampers the communication process. So why are we doing that? What device on the network requires us to have physical addresses?
Right.
Physical addresses. The switch. Because in order for this device to communicate with that device, the frame is going to be passed to the switch, and the switch is going to look at the frame addressing, find the destination MAC address in the frame, and say, hey, you belong to this port, let me pass it out. That's the only reason why we're using physical addresses. Physical addresses are used for local delivery, period. Now, you'll find out that we implement them through the other LANs, but that's because each of those messages that go from network to network are having a private conversation locally with each device, which is why multiple devices on the same network must have the same network address. Now, earlier you heard me say that two or more devices on the same network cannot have the same IP address, but two or more devices on the same network must have the same network address. So in a minute, I'm going to cut you guys loose. I'm going to ask you guys to take this larger network, and I want you to divide it up into 4 equal subnets. Now, before we do that, we need to agree upon some things. We need to agree upon what this network address is going to be to represent that subnet, what the network address is going to be to represent this subnet, and finally, what the network addresses are going to be to represent the bottom subnets. Good about that, folks? Typically, you've been seeing me use the 192.168.something.something address block. And the reason why I use that is because that's a Class C private address space. Private. Private is when we take our networks, divide them up into smaller subnets, and only allow for individuals within that same network to communicate with each other. Remember the 3 reasons why we take a larger network and subdivide them. We either do it by geographical location, by purpose, or by ownership, correct? In this case, we're going to do it by ownership. We're going to be taking this larger, much public network and divide it into private, smaller networks. So, you guys go ahead and explore how to do that. You want to arrange these so they're in the different 4 quadrants of this workspace. Each of these subnets should have what to connect them together? A switch, because we're creating private local area networks. Okay? So go ahead and do that. Let's make the first subnet 192.168.1.0. That's going to be the network address. So therefore, the first device on this network should have an address of 192.168.1.1.
That Class B.
No, this is going to be still Class C. 192.
Oh, okay, yeah, that matches.
So this is going to be subnet 1. Call it network 1. What are we going to do with the other network? This network right up here in the upper right corner.
Dot 2.0.
Makes sense? 192.168.2.0. Make that subnet 2. Technically it's a network. And the third network is going to be?
3.0.
You got it. Now later you'll explore why I'm saying these are technically network addresses But for today, I just want to get you guys familiar with the concept of subnetworks. That is, you take a larger network, you divide it up, and then you try to regain address space. The only reason why I'm doing this is so that you and I can work on the same page when it comes to setting up our routes. So to take this larger network and divide it up into 4 equal parts, I'm going to delete the the switch that's connecting all those devices together. Then I'm going to rearrange my computers so they make a sort of private circle. And inside this private circle, I'm going to add a switch. I come down here to the lower left corner, click on the second icon in from the left called the switch. And I'm going to choose the very first switch on my tool palette. I'm going to click that right between PC 1, 0, 3, and 2. And I'm going to connect these devices together. Come down to the lightning bolt, hold the control key, and click on the auto connect. And I'm going to click on PC 0, switch 0, switch 0 to PC 1, switch 0 to PC 3, and switch 0 to PC 2. Ryan, just sign in, log on to Blackboard, go to week 6, and download chapter 5, LAN WAN file. When you get it, it's going to look like the packet tracer I showed you guys last week, where there was one central switch and all the other devices were connected to that switch. Divide that up so they're in 4 equal subnets. Okay? This network up here in the upper left corner is going to be network 1. This one's going to be network 2. Network, okay, let's make this one network 3, and this one network 4. Okay? Alright, so now that I have these 4 PCs connected together on this local area network, I'm going to configure them. Since this is the upper left computer, I'm going to be using the address 192.168.1, and I'll make this one the first computer. I'm going to leave the subnet alone. Click on PC 3, click on desktop, click IP config. I'm going to make this one .2, so it's 192.168.1.2. Close out of that. I'm going to do the same thing with this PC. Click on desktop, click on IP config. I'll make this one 3, leaving subnet mask alone. Close out of that, close out of the dialog box, and I'm going to click on PC 0, and go to the desktop tab, click on IP configuration, and change the 100 so it's a 4. Let me close out of that. Close out a dialog box. And now I'm going to test for local delivery. Folks, you might want to do this. One of the big reasons that drive us to take in that larger network and divide it up into smaller pieces is it makes it more manageable. Right? When I take that larger network and I divide it up into my first subnet, I'm going to first configure them, and then I'm going to troubleshoot them. So I'm going to ping each other to make sure everything is working before I move on. So I'm going to click on PC 1, click on the command prompt, and I'm going to ping another computer on this network. So ping space 192.168.1.2. And I should get some replies if all is well. Got some times outs. That's a good thing I tried troubleshooting this because I'm obviously having failure somewhere. So let me hover over these to make sure that they're all properly configured. That's one. Oh, there's my issue. I need to configure this one, so it's 192.168.1.2. Now I can try that ping again. So let me click on PC 1, click on command prompt, hit the up arrow to reinstitute that command. And I get replies from this network. So try the same thing with PC 3, and I get 4 replies from this device, and I'm going to try it for the last device. Alright. So now that I have successfully communicate with all my local devices. I'm gonna come over here to this network and connect them together. So this is my subnet 2. Come down the switches and click on the very first switch. I'm going to group these 4 devices around that switch. Connect them together by coming to the lightning bolt, holding the control key, and clicking on the lightning icon, and work my way around the circle. And by the way, if you guys have any questions, go ahead, ask. If you want to follow along, you're more than willing. Click on PC6, desktop, config. Alright, I need to update this device with the new network address, as well as the new host address. So I type in 192.168.2.1 for the IP address for this host. And going around in the circle, I'll continue doing this. So it's 192.168.2.2. And I go to this PC, make this one 192.168.2.3. And then I click on the final PC. Click on desktop, click on the configuration tab, replace the IP address, the appropriate IP address. Close. And then now I'm just going to ping each local host by going to PC6, typing in ping 192.168.2.2, and I get 4 replies. I'm going to ping 3, and I get 4 replies there. And the last device I need to check is PC4, and I have 4 replies. I'm going to close out of those, and let me set up this little local area network. Come down here to the lower left corner, click on switch, click on the very first icon, look somewhere near those other PCs, arrange them like so. Let's connect them together, come down to the connections icon, hold the control key, click on the lightning bolt, click on PC, and switch, and this process just keeps on going on and on. Let's configure these PCs so they belong to the right logical network. So I hit the escape key on my keyboard, click on the first device, go to desktop, click on IP config, and then replace this one so it's belonging to the 192.168.3.0 network. Since this is going to be my first device, I'm going to make this one 1. Close out. I'll make this one .2. This one here .3. So it's 192.168.3.3. And I'm going to make the last one 192.168.3.4. Oops, gotta make sure everything's communicating. So I'm going to go to the command prompt for PC23 and let me ping 192.168.3.2. Get 4 replies. I'm going to do the same thing with host 3. And then I'm going to do the same thing for the last host, host 4. Close out of those. And now let me move on to the last subnet. Come down the switch, click on the switch, the first switch. And group these PCs around this switch. Connect them together. Make PC12 my first PC. Go to desktop, click on IP config. Change this to B4.1. Make PC13 my second host. I change the IP address, so it's 192.168.4.2. Question, Bob?
No.
Alright, let me go back to the first PC, and let me pin the rest of the PCs on that network. So PING space 192.168.4.2. And let me do it for the next host. And for the last host, 192.168.4.4. Okay, how's everybody else making out? We took that larger network, we divided it up into smaller subnets, so this way we can contain the broadcast addresses, correct? So whatever's going on in this upper network, let me close out what I'm doing. It won't bother, so whatever's going on in this upper network, it won't bother what's going on down here in this network. Now, like I said, this sort of allows us to be safer when we're communicating with different devices. Because if this is the administrative side, and this is the student network, and this is the faculty network, the students might be having access to the internet, maybe to a public drive, maybe to each other's files, but they're not going to have access to my files. It's almost physically impossible for them to have access to it, correct? Because in order for devices to communicate with each other, they have to be connected. They must have the same medium, correct? Remember the definition of a network. Two or more devices connect together over a common medium governed by a set of rules to share resources. Unfortunately, when I take this larger network and I divide it up to 4 equal networks, I'm sort of left without. I add security, but I also take myself out of the picture from the students, as well as the administrators. In order for us to have accessible learning experience, we need all 3, plus maybe additional IT services. Does that make sense, folks? So I need to figure out a way to connect these networks back together, but still keep them private. Does that make sense? So what device can we use to connect these 2 networks together? And you can do it many different ways, but you're only going to use this particular device, this particular intermediary device.
Router.
A router. Remember, a router acts as a way out of a network or a way into a network. Now what you guys are going to be doing at the end of class is you're going to be adding 4 routers total to this packet tree. You're going to add one for this network, one for that network, one for this one, and one for that one. However, what we're going to do as a class is we're only going to add 2. We're going to add one between subnet 1 and subnet 2, and we're going to add another one between subnet 3 and subnet 4. Is that okay? So this router is going to act as a gateway for both of these networks. So let's come down here to the lower left corner. And let's click on the very first router icon, the 1841. Now the reason why I have you guys click on the 1841 is because that's what we have in our closet. So towards the end of the semester, we're going to be able to get the real hardware out. And you guys should fall in naturally because you've been using it here on Packet Tracer. So let's click on the 1841. And I'm going to click right between these 2 subnets. Question. What type of medium should I be using to connect router 0 to switch 0? Definition is when you have like devices. Are switches and routers like devices? No. In fact, a router is just a glorified PC. It's a special purpose PC. What did you guys use to connect your PCs to the switch?
Straight through.
Straight through. So let's come down here to the cable, to the connection area. But do not click the lightning bolt. And the reason why I don't want you guys to click the lightning bolt is that we need to know what interface of the router we're connecting to. This is going to make a big difference when we start doing our routing tables. So I want you guys to come down here, come over to the cable selectors, and hover over the thick, straight black line. It should say straight through. If it does say straight through, click on that once. And I want you to click on router 0. Let's choose fast Ethernet 0/0. Remember what interfaces you're using to represent each network. After I click on the Ethernet fast Ethernet 0/0, I'm going to click on the switch. Question. Which one should I pick? Does it really make a difference when I go to connect this straight through cable into my switch? Which port I use? Bob?
Would you use the console so it actually works for all of them?
Okay, that's interesting. A console is used for configuring devices, and those are usually Cisco ports. It's very uncommon to see a console port on other switches or routers. Okay? So, in fact, think about what you said. Can't PC3 talk to any other PC on that network? It's because it's plugged into the switch. The switch manages traffic. It doesn't stop anybody from actually communicating with themselves. You good about that?
Okay.
I could actually plug in the router into 5, 6, or 7, or 8, and they can all communicate with it as long as they know that router's address. Just like PC1 can communicate with 2, 3, or 4. The only thing that PC1 needs is those other IP addresses. What I like to do is I like to plug my gateway into the last port on my switch. Why am I that particular? And some people say anal.
So it's easier to manage what's a computer and what's a router?
Yes. The other thing I have to deal with is, here's one of my switches in this classroom. All these computers are plugged into the switch. If I see a student misbehaving in that first computer in the first row, I don't want to have to ask that student, hey, did your internet go off? I just want to simply come over here and I say, oh, computer 1, port 1, unplug. This is where the logic world meets the physical world. Sometimes I won't have that luxury of my switch being in the same room as my hardware or my devices. In fact, it might be in that closet. It used to be in that closet. And if that happens, could you imagine me constantly making trips back and forth from the closet to a computer to see if it's working or not working in this case? So I'm thinking my gateway is a way out of the network, and why should I just make it the last port on my switch? So this way, when I go to look at it and I want to update it or modify or change whatever the case may be, I know that the last port will be my gateway. This is just a principle, a technique. It's not required. I just like doing it because it makes management a lot easier. Alright, let me come back down to the cable selector. Choose a straight through again. So I'm going to click on this icon right here. I'm going to back up to router 0. I'm going to click on the Fast Ethernet 0/1. By the way, if you guys hear me say FA, that's just a Cisco shorthand. So I'm going to click on Fast Ethernet 0/1. And then I'm going to come over to the switch on subnet 2, and I'm going to pick on port 24. Question. Why does the router automatically turn off those interfaces? I mean, I know they're off because I have these red dots here. And I'm assuming that my cables are the correct cables and they're healthy. Why would a router, by default, exclude these ports? I mean, that's like an extra step. And if things don't work, you're scratching your head like, what did I do wrong? And it's like, oh, I forgot to turn it on. And that will happen in your labs. It's one simple thing of flipping on a switch, and it's causing all your problems. So why would Cisco have their routers automatically turn off the ports that aren't being used, sorry, the interfaces that aren't being used? What does every router have? In fact, what do routers use to pass packets? A table, correct? We call this the routing table. Right now, this interface would represent this network. So when the router boots up and this interface goes on, should this network address be stored in a router's table? Likewise, this interface represents this network. When that interface gets turned on, should this network address be in that routing table? What happens if they weren't in the routing table and a packet comes in to the router? Would the router know what to do with it? No. If it doesn't have a roadmap to pass the packet onto, the packet gets dropped. We call them a route or a pathway. So we turn these off by default because the more and more entries that are added to a routing table will cause what to performance? Will do what to performance? Start slowing down, right? Because as I said the other day when we were dealing with the steps, I said every packet that comes in has to be matched with an entry in the routing table. It has to AND it with the subnet mask. So the more entries I have in my routing table, the longer it takes to find a match. So Cisco is saying if you're not using these interfaces, we'll turn them off. Doesn't it also add for security? If somebody stumbles onto your network and they have a cable and they come over here and they plug right in, would they be negating the reason why we're dividing our networks up in 4 smaller pieces? They can plug in, but if they don't know how to turn it on, if they don't go through the console port to turn on that interface, what good is it going to be? So, let's talk about configuring these interfaces. Let's click on router 0. Now, get used to being spoon-fed this first couple of months in this course. Towards the end of it, you will not have the luxury of this config tab anymore. Okay? You will be learning how to configure a router like we do in the field using the command line interface. But the goal of Chapter 5 is to talk about network theory, routing theory, if you will. The goal of like Chapter 9 or Chapter 8 or 11, one of those last chapters, is going to be about configuring your device. So let's click on the config tab. Come over here on the left and click on Fast Ethernet 0/0. And there's that little pesky box. Put a check mark next to on. Now we're turning it on. Now I have to ask you a question. What do we do with an interface that's being connected to a network? What did you do to those other 4 PCs on this LAN?
IP address.
You gotta give them a rule, right? You gotta have them agree upon the same set of rules. Here we have these 2 boxes and we have to configure this interface so they belong to this particular subnet. What is the network address for subnet 0? Sorry, subnet 1. The 192.168.1.0? Remember folks, a gateway can be considered as a way in or a way out of a network. If this classroom's our network, this is our gateway. This side of this door has to have the same, or be on the same side that we're on, correct? I know that sounds funny, but the only way you can get out of this door is by touching this handle on this side of this door. On the other side of the door is another handle that you cannot touch, right? At least without opening the door. So the only way you're going to leave this network is through this door. And you have to make sure that this door is accessed from inside this classroom. What if I put a brick wall up here? Are you able to access this door? You guys might do that inadvertently by not setting up the right address. If a default gateway has a different network address than one of the local devices, the local device and the network, the gateway will not be able to communicate with each other. Remember the first step in that process that we went over yesterday. Step 1, determine whether or not the packet is local or remote. If it's remote, send it to the gateway. So what should I put in here? Brian, what would you put in here?
192.168.1.254.
Alright, so Brian's using the Class C addressing space that we talked about. These 3 octets match my local network. 192.168.1. Then Brian took it a next step further and said I'm going to use the last usable address for this network. Just like I used the last usable port in my switch, I did the same thing with my address. Could you pick any number from 5 to 254?
Yeah.
Could you pick any number between 1 and 4?
No.
Because 1 and 4 were used by the other devices. Okay? Let's click on subnet mask. The computer should be smart enough to recognize that this is 255.255.255 network. Let's go over here and on the left and click on the Fast Ethernet 0/1. What subnet does this interface represent? So, let's put a checkbox next to on. And inside the IP address, let's type in 192.168.2.1. Bob, what would you recommend?
254.
Last usable? We can do that. And the subnet mask, click in that box. Let's verify that they're on, and they're using the correct network address, and it has the correct subnet mask. Let's close out of this. I'm going to let this boot up. I got 2 green dots there, I got another green dot there. Finally, I got a green dot here. You guys were thorough in the previous task. When you set up your network, you made sure that these devices communicate with each other. When you set up this network, you make sure that those devices can communicate with each other. Now see if PC1 can communicate with PC8. So I'm going to click on PC1. I'm going to go up to the desktop tab and click on the command prompt. I'm going to type in ping 192.168.2.1. Did it fail? But I thought you guys told me if I add a gateway to my network, everything should be peaceful. Let me close out of this. I'm getting request timed out. If I put my finger on PC1 without picking it up, I should be able to go over to PC8. Right? If I can put my finger somewhere in a diagram without picking it up, connect to another end device, I should have communication. Why is that not working? Why is my packet not coming to this device and coming back to me, letting me know that life is good?
Because they don't have the default gateway.
Yeah. Well, I added something to the network. I added a new device, which we're calling it the gateway, but I haven't informed these other devices about that. The other devices didn't realize that they can go out on another network. All they realized was, hey, all our conversations are going to be private, they're going to be local because we don't have a gateway. But now we do. So let me click on PC1, go to desktop, click on IP config, and let me type in for the default gateway 192.168.1.254. Do you notice I'm using the FA0/0's IP address? Because that's the side of the router that represents this network. Now, in the interest of saving time, I'm going to copy that. And then I'm going to go to the other 3 computers, and I'm going to paste that. Ian, here's your shortcut. I know you were asking. I know you were thinking about that. All right. Now, after I get done adding a default gateway, I'm going to click on the command prompt, and I'm going to ping 192.168.2.1, and should this work? Why not, Ian? Why are you shaking your head no?
Only one of the gateways is open, the other one is still.
I haven't configured the other devices on the other network to understand its gateway. Here's a test question. Where in the communication process did this message end up at? So let me close off. I've pinged from this PC to this PC over there. Tell me when to stop my finger. I go from this PC, it goes to what? Did the message stop here? Did the message stop here? Alright, so Bob saying yes, the message stopped there. The PC knew to get it there. But this router does know about this network. Why does this router know about this network? Because it's directly connected. Good about that? So this router should now find the network address in its routing table. In a minute I'll show you how to look for that. So we'll pass it to the switch. What should the switch do next? Pass it up to that PC, correct? Will this PC be able to respond now? So this is where it stops. Because this PC doesn't have a gateway address. So the message will stop right here. Now folks, you can practice this by going to your simulation mode and seeing where it ended. In the interest of saving time, I'm telling you, it's going to stop right there because these PCs aren't configured to use this router. It's gonna look at the destination IP address and it, and realize the network address doesn't match its network address. But since it doesn't have a default gateway configured, it has to drop it. Evan?
I configured mine and it timed out, but then I started getting replies.
Yep, and I'll explain that because the router has to build its ARP table. So then if you hit the up arrow and do it again, you should get all 4 replies. So let me go to PC6, IP configuration. And did that work for you, Evans?
Yeah.
Remember, the router is a device, so it has to build its MAC tables, its ARP tables, its its routing tables as well. It isn't until a network fully converges will you get 100% success. And we're also assuming that it's not overwhelmed by other end devices. And this small network, it should be overwhelmed. We only have like 4 devices communicating with it. Actually 8 now that they're on both sides. Alright folks, let's see if we have end-to-end delivery. Let's click on PC 0 or PC 1, and let's ping another computer on another network. I'm going to ping 192.168.2.1. And what Evan was mentioning is that his first line showed up as a request timed out, but the next 3 came up as replies. Did anybody else experience that same thing?
Yeah.
And if you hit the up arrow and do it again, you should get 4 replies. Just think of it as that initial, oh, I do recognize you now. Let's go on with it. Now earlier I said I'm going to show you guys how to determine what's in a routing table. Let's close out of this command prompt. Let's close out of the dialog box. And let's click on router 0. Unfortunately, Packet Tracer hasn't provided us with a graphical tool to display our routing table. So you will have to do it the way the professionals do it. Remember how we find our own IP address? We go to the command prompt, type in ipconfig. Well, something very similar to that. I want you guys to click on the CLI. And I want you to type in, you notice you have a little prompt here and the cursor's blinking down there. I want you to type in the word N, E-N-D, and hit enter. Hit enter again. And you guys back to a prompt that says router followed by a hash symbol or pound symbol. Alright, very good. I want you guys to type in the following command. Show space IP space route. So you're going to type in this command.
I never came back up.
Your network came back up?
No, I never came back up with something to type into after.
Alright, let me look at that. So you typed in the following command at the prompt. Well, first we typed in end. Then we typed in show IP route. And when you did that, what did you have show up?
No, I missed it. I missed the end.
Alright, so hit enter again. Now type in show. How many networks does this router know about? 2. How many entries in your routing table do you have? 2. You notice each of these entries begin with the letter C? That's because each of those networks are directly connected. They give you a little key up here, C letting you know connected. Do you notice that they represent now those network addresses? Remember the 3 elements of routing table. Destination network address, next hop, and then the metrics, right? Obviously we don't have a metrics for a network that's directly connected. Why is that? What is a metric? A metrics is a unit to measure a route's performance. Is that okay? Typically the lower the number the better, depending on what routing protocol you're using. Typically if you're using routing, like RIP, routing information protocol, it's measured in hops. You want to try to get the lowest number of hops, because that means less routers to go through. You good about that? In this case, there is no hops. These are exit interfaces. So there is no next hop address either. It just says, if a packet comes into me, and it has the same network address as one of these entries in my routing table, send it out of that interface. You see why I made a big stink about doing this manually so you know what interface you're connecting the network to? Otherwise, this won't make sense. Alright. See if you guys can do the same thing with the 2 subnets down below. Connect them together with a router. So I click down here on the lower left corner. I click on the AQ41 series router. I'm going to drop this router between these two subnets. I'm going to manually connect them with the straight through cable. I click on the lightning bolt. Come over here to this area and I click on the straight through cable. What do you guys want to do? Should we make this one FA 0/0 or do you want to do this thing 0/1? You guys tell me. I'm game for anything as long as you don't use them in both places.
So 0.
0 on the left, so 0, 0 over here, 0, 1 over here. Works for me. Thanks, Ian. I'm so indecisive. And I'm going to pick port 24. I'm pretty determined about that one. And we do the same thing over on the left side. Now, I always tell my students, save often. My last class, Packet Tracer sort of bitched out on them, and they lost all their work. So I'm going to tell you guys to save often, and you can save these to my documents and you won't lose them. You'll be able to get them back the next day. So I'm going to go up to File, choose Save, just so if I lose this, all hope isn't lost. Alright, now I'm going to click on the 1841 router. Click on Configure. I'm going to click on that 0/1, which is the right side. I'm going to turn that port on. And I'm going to say the IP address is 192.168.3.254. Click on the subnet mask of all three 255s. Do the same thing on the other interface. Turn it on. So I click up here, turning it on, come down here to the IP address. Type in 192.168.4.254. Click on the subnet mask. I get the default 255s, then followed by 0. Close out. Now that I introduce a new device to the network, I must teach these end devices about that gateway. Just make sure I get this correctly. This was the other good. So IP configuration 192.168.3.254. Control A to select it. Control C to copy it. And then I go to the other end devices. I'm going to do the same thing, but I need to update the gateways to be A4. So it's 192.168.4.254. Control A to copy. That's how I select it. Control C to copy it. And then I go to the other three devices. Holding Control key, hit letter V inside the default gateway box allows me to paste it. And I just repeat. Now you guys are doing your due diligence. Were you guys able to ping a PC from that network over here to this network? Did the first one fail? And then from here on out, all should be well. So if I ping 192.168.3.1, my first line should fail, and then I should get 3 replies. And there they go. Okay. I guess I solved half the problem. Network 1 can communicate with network 2. Network 3 can communicate with network 4. But can network 1 communicate with network 3? What do you guys think? What would you do to connect this network to that network, and this network to that network, and this network to this network, and this network to that network? You guys gonna throw some more routers in there?
Yeah.
Oh, come on. I know money doesn't mean anything in a packet tracer, but in the real world, you just lost your job.
I have a question.
Yes.
Now, they only have, well, 3 connection ports for the routers if you count the console. But
Can't.
there's only 2.
Console's only used for
Right,
configuration,
Right.
so.
But there's only 2 ports used.
That's right,
So
2
that's
interfaces.
why we can't just use one more router to connect them.
Well, There's a lot of different ways of doing this. What Ian's mentioning is that we only have two interfaces on board with this router, okay? Just like when you guys buy a computer, you probably only get one interface built onto your motherboard. But what can you do with your computers?
Upgrade.
You can upgrade them. And I told you that a router is just a special purpose computer. So listen up, I know you guys are eager to do this. But before you can upgrade your computer, you have to turn it off. But if you turn off these routers, you will lose all the work you just got them doing. Just like if you forget to save something on a PC and you turn it off, poof, it disappears. All the work we did was stored in a file called running config. We need to save it to a file called startup config. Okay? So what we're going to do is we're going to click on router 0. We're going to click on the config tab. And remember, you're being spoon-fed here. Later you'll be learning the CLI commands to do this. Let me click on the config tab. And you guys see this little command that says save to NVRAM? Translation, you're going to save the running configuration file to the startup configuration. So when your router reboots up, it'll load all your work. So just click save. And yes, folks, it's that easy. You know what? Do you see this host name and this display name? I want you guys to change the display name so it's R1. And do the same thing with the host name. Now, I'm not going to have you save this, but I want you to notice after you get done changing the display name and the host name that the dialog box name changed up here. This is me illustrating my point, that when this router boots up, this will disappear. Let's come over here to the physical tab. And like I said, in order for you to upgrade your computer, you have to turn it off. So let's click the power button to turn it off. Green light should disappear. Now in my last class, a lot of students are grabbing this modular and dragging it in there and thought, well, you know, that's forward thinking. But with this modular is actually a switch. Switches cannot handle multiple networks. It's for one single network. You good about that? It's a LAN device. It's not a routing device. All you're doing is like building what we call an integrated service router. You guys have that at home, your wireless router. It also has 5 ports in the back of it, doing 2 jobs. Over here on the left side, you see a whole different other modules that you can add into it. I want you guys to pick on the WIC2T. This is going to allow us to have 2 serial ports to a router. Down here in the lower right, you see this modular. Click and hold and drag it to slot 0. And this is us upgrading our router because, as Ian mentioned, all I have is these 2 ports. The console port is for configuration, and then the auxiliary port is for a backup, usually like a dial-up mode. Let's turn this thing back on. Watch what happens when I turn it back on. It's going to be booting up. And if I click on the config tab, it's going to yell at me and say, whoa, 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 I haven't uncompressed your file, give me a second. So I'm going to click OK. Wait for it to get done booting up. You notice the host name went back to what? Because I forgot to save those changes. Okay, why don't you guys do the same thing to router 2. Come down here to the other router. Go to the config tab. Change the display name so it's R2. Change the host name so it's R2. Then click the save button. After saving, click on the configuration tab, the physical tab. Power down the router. Over on the left, click on the WIC2T modular. Grab the modular over here by clicking and holding and dragging it on top of slot 0. Power up the router. Close out. I'm impatient, so I'm going to click the fast forward button. Now, Ian, did we overcome your interface limitations? Could I have added another series of fast Ethernet cards? Yes, I could have. I just wanted to teach you guys that a router also acts as a bridge between 2 different mediums. Here I'm going from Ethernet to a point-to-point protocol, which we're going to be using serial. Okay? Let's try that. Let's come down here to the connect, so a little lightning bolt. And the question I have is, what type of wire or medium am I going to use to connect these two routers together? And wouldn't it make sense just to connect these two routers together without adding another box or another device? I mean, naturally, you could have thrown a switch in here and then maybe had everything go to the switch and make a mess out of things. It would have worked. But it would have been so easy to manage. The other thing we could have done, like you guys will be doing at the end of lab, is to add individual routers and then throw a switch in the middle of that, and then have the routers connect to the switch. Folks, isn't that what we did to this? We broke the network down, we added a switch to all these local devices and had them connect to the switch. Wouldn't this just be another network here? In fact, how many networks do you see right now? One network here, one network there, one down here, one down here, over there. So we have 4 networks, correct? We're going to create a 5th network right now. We're going to connect these two together. The thing is, we're following a different protocol. This protocol uses a point-to-point, and it requires us to set a clock rate. What is a clock rate? What is the role of a drummer in a band? And how many drummers are in a band?
Well, if you're the Trans-Siberian Orchestra.
Well, they're a little out there. But traditional bands.
You get one.
One, why? And what is the role of this drummer?
Keep the rhythm.
Tempo.
Yeah, the beat, the tempo, right? A clock rate to a computer is what a drummer is to a band. Let's use these lights as an example of how everything works out. You guys can tell me what's a 1 and what is a 0 if I do this. Because you can see change. But what if I want to represent something like this? How do I go from a 1 to another 1? Do I quickly do this? No, because that's voltage being changed, and that's going to recognize as a 1010. So I set a clock rate. You guys can look at that clock, and every time that little red dial goes past the number, you'll say, okay, that's new time. So have the lights changed? How many times does that right hand go past the number? Right now I'm up to 4 times. So you'd write down 4 ones. You see that the clock is dictating the change, how often the change occurs. Is that what we call a rate anyway? The time it takes for something to change? So the clock rate is telling us how many seconds you are to use to recognize a change. You good about that? Now I bring this point up because only one of these devices has to be responsible for the clock. The other device becomes a terminal, a slave to that clock. You good about that? The device that's responsible for the clock we call the DCE. The other device we call the DTE. When you guys come down here to the connections tool, over on the right, as you scroll through your tools, you will see these little red zigzags. One will have a clock. What do you think that serial connection is going to be? The DCE. Let's click on that. When you click on this, it's telling you the very first router you're going to click on is going to be the one that's going to be the DCE. You good about that? So I want everybody to click on the R1 router. And what are we going to pick? I'm not going to choose the common support, right folks? It's only for configuring.
0, 0.
We can do the 0/0/0, or we can do the 0/0/1. It doesn't matter. Let's pick the 0/0/0. Now we're going to come down here to R2. Which one are we going to pick after we click on R2?
Same one.
You could for management's sake, but does it matter? No. But I am going to pick the same one just for management's sake. Isn't it funny that when I hooked up my Ethernet networks to my router, the lights were off, the interfaces were turned off automatically. But when I hook up my serial interfaces to my router, they're turned on automatically. They are what they are. Now, folks, how many networks do we have? 5. How many network addresses have they given you so far?
4.
What are we going to do about the fifth network? First of all, what is the fifth network? It's this area right here. Right? What's the network address for this network? You guys are the administrators. You tell me, what do you want? I usually pick an exotic number. And the reason why I pick an exotic number is because, one, I don't want it associated to a private network. This is a public network, if you will. In fact, if I add switches, they become really public. Just like that hallway is a public hallway, but this classroom's private. So what I call you in this classroom might be different than what I might call you in a public area. Okay? What do you guys want that to be? Any number from 0 to 255. You tell me. My last class decided to make it 192.168.0.0 because we haven't used that yet, and that's available because it said any number between 0 to that. But you know, it sort of caused some confusion, right? Because it's like 192, and I want them to associate the 192 to be with these private lands. So, Ian, give me a number between 0 and 255.
42.
42, that works with me. Ryan, give me a number between 0 and 255.
67.
67. Evan, give me a number between 0 and 255.
88.
Okay, so your new network address is going to be 42.67.88.0. Your subnet mask for this network is going to be 255.255.255.0. Make sure you put that in there, okay? Let's see how we're going to configure this. We're going to click on router 1. Actually, would you guys like a challenge to break away from that 255 crap? You want to see what we can do for the fourth octet?
I don't understand why it's 255.255.255.
I made it that way.
Because the default when you hit tab was 255.0.0.0.
That's class A.
Yeah.
But you know what? You need the challenge because you're asking that question. Where are those numbers coming from? What do they represent? Well, let me close out of this and let me ask you guys something. How many hosts are allowed to be in that network? See here, this can scale up, correct? I can keep on adding new devices onto the switch. It's not going to affect anything. It'll just make this network become a little bit slower, quote unquote. But I cannot add any more devices to this point-to-point. This is like that little string telephone cup that you guys had when you were kids. You have a cup here and it'd go to somebody else, right? It'd only go to somebody else. Now apparently people said you can actually tap onto that one common string and it would work. I don't know if I believe that. But nevertheless, that's what we have. One styrofoam cup here, another styrofoam cup there, and we're connected together. We good? Only 2 hosts. Remember, an IP address consists of 2 parts. What are the 2 parts?
Network and host.
Networking address plus the host address. Right? Over here I said these are our network addresses and you're not allowed to use them. A network will contain a network address, host addresses, and a broadcast address. We good about that? How many hosts are in our network? In this network, there's only 2. That's only one network, correct? And for every network, we will have only one broadcast address. 1 plus 2 plus 1 gives me 4. We good about that? Each octet, by the way, next week we'll learn this in binary, but it's going to stay in decimal. Each octet is made up of 8 bits. 2 raised to 8 gives me a total of 256 unique possibilities, correct? Do you notice they said you always have a number that you can pick from 0 to 255? Folks, I have 10 fingers, but they go from 0 to 9. We always include 0. You good about that? There are 256 numbers from here to there. Let's take 256 minus 4. Why am I subtracting 4 from it? Those are the number of addresses I have to make sure I have, correct? What do I get when I take 256 minus 4? Now, this is telling me that my new subnet mask is going to be what? So the address was 42.67.88.0, but my new subnet mask for this network is going to be 255.255.255.252. When do we use a subnet mask? To calculate the network address, correct? And what I'm saying in binary, there's all these ones up to this point except the last two. When I say the last 2 bits are going to be used for the host. 2 raised to 2 gives me 4, right? How many addresses did I need for this network? 4. A network address, 2 host addresses, plus a broadcast address. You're starting to see why we use where the subnet masks come in. Okay? So there's the challenge. Let me click on R1. Let me come over here to the left, click on serial 0/0. Notice it's turned on and I have this like 2 million, I'm going to use that for my clock rate. Like 2 million bits per second if we will. And come down here to the IP address and I'm going to type in 42.67.88.1. I'm going to make this router the very first usable address, correct? Because 0 is the network address. But underneath subnet mask, as you guys told me, it's going to recognize this as a class A, so it's going to give me the standard. And I'm going to modify that standard so it's 255.255.255.252. I'm going to close out of that. I'm going to go back to R2. I'm going to come over here on the left and click on config. And I'm going to click on serial 0/0/0. Remember, I'm on the second router. Come over here on the serial interface for that. Do I need a clock rate for this router?
No.
No, I already have it set for the other router. So I'm going to come here where it says clock rate and choose not set.
What did you set it for the first router?
2 million, it doesn't matter, you pick any number, that's net drop down list. Obviously the better the number, the faster it is, but make sure the distance of the router is closer. You have a timing issue if that wasn't the case. Okay, IP address. Well, 0 was for the network, 1 was for the other, the first router, correct? So what should this one be? 42.67.88.2. And then what am I going to put for the subnet mask? The same subnet mask as I did with the other router. 255.255.255.252. Now, in a couple of weeks, you guys will understand what we did was we optimized that address block. Initially, this address block could have handled 16.8 million devices. If I used it here, I would have wasted 799,998 addresses. Good about that? But I said, hey, my subnet mask allows me to take a larger block and divvy it up, which we call subnets. And I'm saying that my width of my subnets are only going to be 4. So the next network address is going to be 42.67.88.252. 6.4. But like I said, that's going to be for chapter 6, and we spent a lot of time on this, on chapter 6 stuff. It was laying down the groundwork for us to build from. Now can these networks ping each other? Try it. I promise you will fail miserably, but that's the way we learn, through mistakes. The question I might ask on the test is, why did you fail? Why did it not work? Ask yourself this one common thing, get used to doing that. What networks does this router know about now? Router 1. What networks does it know about? 3. What 3?
1, 2, and
This network, and this WAN right here. Correct? Why does it know about those 3? Because they're directly connected to them. What networks does R2 know about?
3, 4, and
This one, and this one. Correct? So network 3, network 4, and the WAN. Which networks does R2 not know about? Why does it know about those? Why does it not know about those networks?
it's not directly connected. There's no flow of information.
Nobody taught him about that. A router can learn about networks by 2 forms. Manually, which we call static, or dynamically, when they talk to each other. I'm going to teach you guys how to do this manually, okay? Maybe tomorrow in class we'll do it dynamically. Let's go into R1. Click on the config tab. Underneath the routing group, click on static. Now RIP is an example of a dynamic routing protocol. Do you see it's going to ask me for 3 pieces of information? The network address, the mask that represents that network, and the next hop address. Ask yourself this. You're on a router 1. I can see that up here. Which networks does this router need to be informed of? Which networks do you need to teach this router about? Ian, you said didn't know about what network?
3 and 4.
3. What's the network address for network 3?
192.168.3.0.
Do you see where the network addresses are coming in now? Network addresses are stored in a routing table because it's convenient to address a large group by one address instead of individual computers. Go to classroom C002 to find Bob. Instead of, well, go here, go there, let's add everybody to one routing table. Does that make sense, folks? Next thing, the mask. In yesterday's class I told you that each packet that comes in will be AND with every subnet mask stored in the routing table. The subnet mask I want to give this router is a subnet mask that matches that network address. What was the subnet mask for that network address? The 3.255.0. We kept true to the class, right? So we put in all 3 255s followed by a 0. What am I going to put in for the next hop? This is where you get out your finger. You're not going to pick your nose with it. You ask yourself, if I'm here and I want to talk to somebody over there, what path should I follow? So I click on PC1, come down to the switch. Where am I going to go to next?
Router 1.
I'm here. This is where I'm configuring it, right? I want to teach this router about this network. In order to get from here to there, where do I need to hop to? I need to go down here. When I come here, what is the very first interface I come into? So here I am. I'm at this door. What is the number on this door? Now, remember what side of the door you're on. In this case, I'm actually on the other side of the door. What number am I going to use as my next hop address? Am I going to use the private side of this router that gets to this network, or the public side of this router, which this router can communicate to? You guys tell me. Yeah, it's going to be the one, sorry, it's not the one, it's going to be 42.67.88.2. Do you see why I wanted to change it up? Because I can see why you guys are thinking 192.168.0. Well, isn't that like a private address? Does that make sense? I wanted to just give you a different address so you don't add to the mess. What else does this router not know about? Network 4. So I can come right up here to this network block, change the 3 to a what?
4.
Do I need to change anything else? In this case, no. Because the only way this router can pass packets to is the only other router at the other end. Imagine if it's just you and your friend in a room. Do you need to address them by their name? If you want them to pick up a hammer, bring you paper, you can just say, hey, can you bring me paper? Not, hey, Brett, can you bring me paper? And the reason why I had to address Brett is because there's many of you in this classroom. But if it's just Brett and I would just say, hey, Brett, I would just say, can you grab me some paper? And when I ask, do you have any questions? It's referred to only the other person on the other end. So when I click add, my router now knows about these two networks because it's in their routing table. Let me close out of that. What do you think I need to do to router 2 then?
About 1 and 2.
I need to teach router 2 about these two networks up here. Smaller, manageable size, very repetitive, but easy for us to control. So let me click on R2. Let me go to the config tab, click on static underneath the routing group. And in the network address, I'm going to type in 192.168.1.0. What am I going to put in for the subnet mask, folks?
255 cubed. 0.
So the 3 255s followed by a 0. What am I going to put in for the next hop address?
42.67.88.1.
Yeah, remember, you're here. The only way out to get to these networks is there. So what is the address for that device? That's the 42.67.88.1. I'm going to click add. Then I'm going to go back up here to that network box, change the 1 to a 2, and click add. Check to see if you guys have end-to-end delivery. The first 2 might fail on you because now we're going through 2 routers, but after that, everything should be well connected. So I'm going to ping 192.168.3.1, and like I said, the first 2 might fail on you, but from here on out, everything else should be successful. Actually, it was only my first 1. Did you guys just get your first 1 to fail?
2.
Was it 2 for
2
you?
for me.
And if I hit the up arrow again and re-execute the command, I should have the same. It seems like a lot of work to take what was once simple, throw everything on one switch, and divide it up into 4 separate networks, and add routers to interconnect them together. All right? Oops, let me close out of this. Let me close my screen down. Let me give you guys a little quiz. In fact, I would encourage you guys to try to do this at home with packet tracer. Right now, we have the 192.168.1.0 network connected to a router. This router also connects the 192.168.2.0 network. Then it's connected to another router, which joins these networks together.
192.168.4.0 and the 192.168.3.0. That's the old network. Let's create a new way of doing it. One 192.168.1.0 has its own router. 192.168.2.0 is connected to its own router. 192.168.4.0 is connected to its own router. And 192.168.3.0 is connected to its own router. How are you guys going to connect these four routers together? What device will you use? Yes, you could have done this. Because each of those routers will have two serial ports, correct? But I don't want to do that. I freed up an Ethernet port. Because each router only represents one network now. Before, each router represented two, private, one public. Can I just add a switch? After all, didn't I tell you that a router is just a special purpose computer? How do we join computers in a private network together? Through a switch. I have 5 networks. I have this network right here. I have this network right here. This network right here. This network right here. And lastly, this network right here. The question is, how many static routes would you have to enter in total to get every network to communicate with each other? Go back to this router right here. Ask yourself, what networks does this router not know about? We can rule out this network, right? It knows about that one. We can also rule out this network right here, right? Because it knows about that one. What does it not know about? Does it know about this one? Does it know about this one? Does it know about this one? Isn't the same true for the other ones? This router knows about this network and that network, but it doesn't know about this one, or that one. So if each of these routers don't know about 3 other networks, and there's 4 routers, do the math. How many routes would you enter in? 4 times 3 is 12. Wow. And that's why we start to learn about dynamic routing protocols. Because if you make one mistake, you can bring down a network, you can bring this network down, and it won't be able to communicate to the other networks. So tomorrow in class, we'll explore dynamic routing protocols. Just set up ARP. It's real simple. All you have to do is tell the router what networks it knows about, and you're done. And then they'll start to converge, and they can all communicate with each other. All right? You guys take care. I will see you tomorrow in class.